Alright, so let's do this. We're going to be in both your note packet, the white packet, and your homework packet today during the notes. Because I want to do a homework problem last night as part of the notes, just as an FYI. Okay? So I'm not going to check homework until after the end of class. What was that? I said no.
No.
I said no.
Oh my gosh, Tom.
No Supremo.
No soup.
Okay, so we're going to start on page 11 in your note packet. There's 2 on the retrievals of filling in the tables, okay, and then there's 2, give me the recursive and the explicit functions for those 2, okay, so those 4, I'll give you 5 minutes to do those. Hammer time. So in that first warm up, so the f of x value, if I plug in 0, would be -5. If I plug in 1, it would be -7. 2, -9. 3 would be -11. And 4 would be -13. On the other one, x minus 11, so then that would be -11 there, -10, -9, -8, and -7. Agree with me on those?
Yes.
Okay. Really, you only need to put 1 in there, and then you could have used the slope to get the other ones. Okay. Explicit and recursive functions going on here for this one. So here I am multiplying by 1/3. 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 So clearly I am multiplying every time by 1/3. So f of n is equal to 1/3 times f of n minus 1, but we also need to have a placeholder, so I'm going to use f of 1. Okay? You could have said f of 2 is 27, f of 3 is 9, f of 4 is 3, f of 5 is 1 there, but I used f of 1. Okay? The explicit function then for this one would be f of n equals 81 times 1/3 to the n minus 1 power. Or you could have gone 27 times 1/3 to the n minus 2 power. And so on and so forth. Okay? On this one, looks like we are going subtracting 8, subtracting 8, subtracting 8, and subtracting 8. So my recursive function would be f of n equals f of n minus 1 minus 8, and I'm going to get a placeholder of f of 1 is 45. Fine, don't do it. Oh, either. So then my explicit function would be g of n equals -8n plus 53. You might have written it in this form. You might have written it in that blue form, but when you simplify that blue form, you get the brown Questions, comments, concerns, clarifications on those? Yes, ma'am. He would. All right. So let's jump to number 2 in your note packet, which I believe is on page all the way to page 14. Something says that it's on page 14. Yeah, number 2, up there at the top. It says we would like to do the domain, the range, the maximum, the minimum, the intercepts, and intervals of increasing and decreasing on this pictured function. Okay? All right? So if I'm talking from yesterday, if I'm talking about domain, what am I looking at? Not what is it for this problem, what do I need to find from yesterday? We can turn back if we need to turn back. What do we need to find if we're looking for, or what do we need to look for if we're looking for domain? X values, first and last X values. So is that horizontal or is that vertical? Horizontal. So it looks to me, for me, it looks like we are, the farthest left we are is over here at -6, 7, -8. And the farthest right we are is over here at 10. Would you agree with that?
Yes.
Okay? So that means that my domain then would be from -8 to +10. Remembering that in interval notation, that the small number, comma, big number, and then there's some crazy combination of, you could have parentheses or you can have brackets. And parentheses don't include the number. Or it would have an open dot. Okay? And a bracket includes the number, and it would have on a graph, it would have a closed dot. Okay? All right? So we're good there. Range. What am I looking for on my graph in terms of the range?
Like the smallest number and the largest number.
Where? Y values? Small and big Y values?
Yeah.
Okay, is that horizontal or is that vertical? That's the vertical then. Okay? So it appears to me that we go down here to -3 and we go up here to 5. Would you agree with that? Yeah? Okay. So my range then would be from -3 to 5. Yes? Okay. All right. Maximum. What does it mean? What does the word maximum mean outside of math class? Most, right? Biggest? Okay, right? So am I looking for the biggest X value or the biggest Y value?
Why?
Looking for the biggest Y value. So the biggest, tallest Y value would probably be right up here. Would you concur with me on that? So that biggest Y value would be 5. And where does that happen? At X equals 10. Okay. This one over here, kind of in here, that would be what's called a local maximum, but it's not the maximum. Okay? It's kind of like it's the biggest Y value here in Wausau, but it's not the biggest Y value in the state of Wisconsin. Okay? It's a local maximum is the biggest value, just kind of around it, but not of the whole function. That would be the absolute maximum, which is what we're looking for. Okay? Minimum. What does minimum mean? The lowest, the smallest, right? Okay? All right. So where is my minimum?
-3 at x.
-3 at x equals -8.
Yes.
Yeah, I would concur with that. Okay. Intercepts. Okay. What is an intercept? Where the function
Where one function equals 0. Like one. I don't know what I'm trying to say actually.
coordinate,
Yeah.
where one coordinate equals 0, so I would accept that.
Where the line or the function goes through one of the axes.
Where the function crosses an axis. Okay? Those are both same, they're saying the exact same thing, just in a different way. So I would have one intercept right here, and I would have one intercept right there. And I don't see any other ones. Do you agree with me on that?
Yes.
Okay? So that means I would have an x-intercept. I would put the x-intercept at -6.4.
Yep. Or
4. It's not quite halfway. Comma 0. Would you agree with that?
yes.
Okay. I would put the y-intercept
Positive.
positive 4.2.
Yeah.
Okay. But it would be 0 comma 4.2, correct? Right. Just let them go. And then lastly it said, let's talk intervals of increase and intervals of decrease. Yesterday we talked about these also. What did we say the function was doing if it was increasing? It's doing what? It's going up. Okay? And if it's decreasing, it's
Going down.
going down. In which direction are we working when we look at that? We're always working left to right on that. Okay? So let's start on the left side. If I start on the left side, what is the function doing here?
Increasing.
It's increasing. Still increasing. Still increasing.
Stop. Decreases.
Stop right there. Okay. Then what happens to my function? Now it goes down, so it's decreasing. Okay. Stop right there. At that should have been. I should have said that this right here would have been a local minimum. Okay. Then what happens? Then it's increasing again, right? Okay. So the intervals of increasing would be from -8 to
Probably -1.
-0.5, maybe?
Yeah, -5.
-0.5. Okay. And then it's increasing again from 7. I would say 7.
Sure, it's not.
7 to 10. I'm sure it's not 6, 7. I heard you, Ty. I heard you. Okay. Now, because there's 2 of them, what do I have to put in between? A U, a capital U, saying that those 2 are together and that they mean this. They're both increasing. Okay. And then it would be decreasing from -0.5 to 7. right? Agree with me on all of that?
Yes.
Yeah. All right. Love it. So, green packet now. Last night's homework, number 7.
Sure.
I'm positive it was number 7.
Which one?
Okay.
Oh,
This one?
So number 7, it's asking us to do all of those things. So let's do all of those things. The context of the situation is that we're talking about altitude in thousands of feet during a trip up and down the mountain. Okay? So the first question it's asking is, what is the highest altitude reached during the trip? 11,000 feet. Okay? Because it would be the highest would be the maximums, which would be up here at 11, but altitude is in thousands, so that would be 11,000 feet. What? No, because it's not asking you for the point. Yeah. It's asking for you just the highest altitude. Okay? Next thing, and it said, so let's do increasing and decreasing. When is it increasing?
0,
0 to 5? Do we agree with that?
Yep.
Okay. When is it decreasing?
5 to 20.
So this whole time over here, even though we're going at different rates? 5 to 20? Okay. Next one said minimum and maximum. I'm going to do the maximum first because I have to scroll down or scroll back up in order to see it. The maximum we already said was 11,000, right? At x equals 5. So we should be a little bit more specific with that because we're talking about it. So could we say 11,000 feet at x equals 5 hours? Because there's labels in the problem, we should put labels in our answer. Okay. So that would be our maximum. Minimum.
2,000 feet at x equals 0 hours.
0 or 20. Ooh.
What did you say there, bud?
0 or 20.
Or?
Yeah.
Or?
And. Comma. And.
And 20, right? Because it's both at both of them, it's 2,000 feet, which also makes sense because if you're going up a mountain, you're probably going to come back down to the same spot, right? Okay, so this would be and x equals 20 hours. Okay. What would my domain be then?
0.
0, 20 in brackets.
What would my domain be then? 0, 20?
Yeah.
In brackets?
Yes.
Very good.
Maybe question myself there.
You made me question it too because I was thinking range.
I was like, wait.
Yeah.
did I
I'm like,
say
wait.
this what?
Yeah, it took me a moment to process too. What would my range be then?
Bracket 2, 11 bracket.
1,000, comma 11,000.
Well, like 2,000, 11,000 because it's in thousands. Yep.
Interesting.
That was sick. Thank you for your input.
Okay. Fast fast forward now to tonight's homework, which really isn't going to be assigned until tomorrow, but you could start it tonight. Okay? Alright? So if we're fast forwarding there, we are also going to be skipping number 11. Okay? We're going to skip number 11. Nope, that's the wrong number 11. You have to do that number 11. On tonight's 3.3 homework, yes. That's the 3.2 homework. We already skipped 4 problems out of that one. See how this is on page 11? And that homework 3.3 doesn't start here until page 12? With me? Okay? See, had you done your homework
Oh,
last
I
night,
did
you
do
would've
my
already-
homework
last night, I didn't.
You know,
I
Sean.
thought this
Oh,
was
you
the,
can't
I
fool a
thought
math
this
teacher.
was the last page of the homework.
You can't fool a math
Yeah.
teacher.
Oh,
I forgot
Our
it.
homework
right.
tonight,
You
guys.
can't fool a math teacher.
Yeah,
Nice
yeah.
try.